this rectangle was rotated around the x-axis, you would see that it would make a cylinder. You would find the volume of the rotated solid by using the volume of a cylinder formula V equals pi r squared h. In this case, r would be the width of the rectangle and h would be the length. So you would plug in the length and width values to find the volume of the rotated solid. Now what if you wanted to rotate a function around the x-axis? This isn't a shape we've seen up to this point in math, so what would you do? To figure out the volume, first recall what the original graph looked like. We'll call this function r of x. To find the volume, we'll use integrals. Remember when we used integrals to find the area under a curve? We added up all of the y values, or r of x, to find the total area. We'll do something similar with finding volumes of rotated solids. Now let's look at the rotated solid again. If we cut it up, we can see that the solid is just a lot of circles, or disks, added together. The radii correlate to certain y values of the graph, or r of x values. Because of this, we can conclude that the radii, or r, equals r of x. The area equation of a circle is pi r squared. The volume of the solid can be found by adding up all the areas of the circles, and you can do this by using integrals. The disk method equation is volume equals pi times the integral of r of x squared dx. To be able to use the disk method, there are certain requirements for the function r of x. First, the graph of the function has to be in the first quadrant. If it isn't, then you can't use the disk method. Also, even if the graph is in other quadrants, you only rotate the part in the first quadrant. Second, the graph of r of x needs to be flush against the x-axis. In other words, the graph needs to be touching the x-axis. Next, the equation has to be in terms of x. And finally, you need an interval for the integral in terms of x values. Now let's try an example. Find the volume of the solid formed when r of x equals x squared is rotated around the x-axis on the interval 0 to 2. I'll just underline and rewrite the important stuff. The function is in terms of x and we have an interval. When we graph it, we find that the graph is in the first quadrant and is flush against the x-axis, so the disk method can be used. Now I just plugged in all the givens into the disk method equation. Let me simplify that. Now differentiate and use the first fundamental theorem of calculus to find the answer, which turns out to be 32/5 pi. Now let's try an example where you don't have the interval. You have the function r of x equals negative x squared plus 4x, and you want to rotate it around the x-axis. So if you graph it, you can see that the graph is in the first quadrant, and it is flush against the x-axis. If you take the zeros of the function, you can find the interval to be 0 to 4. The function is in terms of x, the graph is in the first quadrant, and is flush against the x-axis, and we have an interval, so you can use the disk method. Plug in all of your givens into the disk method equation. You can use your calculator to solve this integral by going to Math 9. For the answer, you get 512/15 times pi. To review, in order to use the disk method, your function has to be in terms of x, you need to have an interval, the graph needs to be flush against the x-axis, and the graph needs to be in the first quadrant.